1. We're going to be looking here specifically at what we mean by signs in fractions, because you have to understand some pretty basic concepts involved with the signs in fractions. A rational expression of this form, A over B, is defined as such where A and B. I want to hear for a second. All right. So a rational expression in the form of A over B, where A and B are both integers. Okay?
Yeah.
You don't know what I mean by an integer? Numbers like 1, 2, 3, 0, negative 1, negative 2, negative 3. All right. So our integers, some people aren't sure what I mean by that. Integers are numbers like your numbers. Okay? Those are referred to as integers. Let me go ahead and say a few other things. Your natural numbers, all right? Your natural numbers, they're like your counting numbers. In other words, sometimes they're referred to as your counting numbers, all right? That would be numbers like 1, 2, 3, and just counting on to infinity, okay? When you see me put dot, 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 that means infinite direction in either direction. For integers on either side of the number 0. Natural numbers, you start counting at 1, 2, 3, and you just keep on going forever in a positive direction. Negative numbers are not what we would call a subset of the natural number system. They're only positive. We would say that the natural numbers are a subset of integers. Furthermore, whole numbers, all right, that would include your number system that starts at 0, 1, 2, 1, 2, 3, and keeps on going. So your whole numbers are only different from your natural numbers because they start with the number 0, then continue on in the positive direction forever. Your natural numbers would be considered a subset of your whole numbers. Your whole numbers include the number 0 as well. Your whole numbers would be considered a subset of your integers, which also include the negatives of all the positive numbers. Okay? There's some other number systems, but those will be the main ones, mainly integers that we're going to concern ourselves with in this. But getting back to this expression, A over B. All right? Let me do this. If I have a negative A over B, an equivalent way to write that would be A over a negative B, or still yet a third way, a negative A over B. Now, in each one of these three expressions, they're all equivalent expressions, but they're understood a little bit differently from each other. In the first one, we're defining the integer in the numerator as a negative number, and the integer in the denominator as a positive number. The overall value is negative, but specifically the elements involved here, only the numerator here is negative. Now you move on to the second expression, we're defining the numerator as positive, and the denominator is negative. Still the overall value of it is negative, but specifically we're giving a negative, and you might say to the denominator, a positive to the numerator. You can move the negative around in a fraction. Now over here at the very end, I'm defining the overall value of the entire expression as a negative, but individually the numerator and the denominator are understood as positive numbers in the context of the fraction itself. All right? So the reason I'm going to bring that up, it's going to definitely pertain to your assignment that I'm fixing to give you on page 71. But just know this too, that your rules for signs are the same as in multiplication. Okay? Rules for signs. Okay? And that is this. 2 negatives equal positive. Okay? Okay? That's basically what you need. You also know that 2 positive times a positive is equal to a positive. Opposite signs equals to a negative number. So what I have here in each one of these fractions, the denominator is understood as positive up here with the negative A in the numerator. Up here, the A is considered positive, the B is negative, and over here the A is positive, the B is positive, but the overall value is negative. Let me say one more thing about this. So that simply means this. In any fraction, you've got three signs that you have to contend with. The sign of the numerator, the sign of the denominator, and the sign of the entire fraction. So if I have just A over B here, there are three signs you have to contend yourself with. There's positive here, and a positive here. There are technically three signs there. All right. I hope this seems simple because we're going to build on this in just a little bit. But also, if I've got a negative A over B, I've got three signs here as well. Okay? So another way to look at this is that an even number of negative signs in a rational expression is going to kick out a positive number in the end. So that a negative A over a negative B with a plus out in front is going to equal to a positive A over B.
How is that positive?
The overall value, I'm stating here, there's a sign out in front. The overall value of the fraction is still negative. I'm just saying technically, with any rational expression, there are three signs in here. If you see a negative anywhere, it's really negative. Okay? It really is. I'm kind of getting technical here, and it will help you in a little bit. But there are three signs here as well. I'm putting a positive out in front. But what if I said this? If I said a negative over a negative, and also assigned a negative value to the entire fraction, I've got an odd number of negative signs here. So what's the overall value of this going to reduce to as a negative A over B? A fraction in its simplest form is defined as having the numerators and denominators, by the way, both identified as positive expressions, while the value of the fraction itself is negative. Okay? This is just some of the theory behind what we're about to do here. If there's anything else I need to say about this before we move on. Let's go ahead and move on. Maybe it'll come to next page. All right. Did y'all get all that? Do I need to back up? Maybe going too quickly. Again, page 71. All right. Let's look at number 1. Okay. Number 1. This is the problem. Now, what are the directions? The directions say reduce the fractions in terms of positive. Reduce the fractions in terms of positive. Right now, both of my terms are negative. But what do we know about our rule for signs? What is a negative 2 over a negative 3 going to be equal to? 2 over 3, right? Okay. What if I said this? What if your problem was a negative 2 over 3, and I gave you the same direction? Reduce to a fraction whose terms are positive. I'm not saying make the overall value of the fraction positive. I'm saying define both the numerator and denominator as positive numbers. What that basically means is this, guys. Just kick the negative sign out in front of the fraction bar, negative 2 over 3. So technically I would say I've got a positive 2, a positive 3, and then the overall value is a negative. That's just a technical description of what's going on here. And remember, any even number, what you can do, any even number of negative signs that you see translates into a positive. But if they're an odd number, it's a negative. So that if you had a negative 2 over a negative 3, a negative out in front, okay, that would reduce to a negative 2 over 3. Throw 2 the negatives away. Throw them away and just keep the negative out in front. Now, I want you to be careful about something here. Let me jump over to number 3. Number 3. Number 3, what I'm going to do, this is the problem. A negative, r plus s, over a negative u minus b. Now, you might be tempted to look at a problem like this and go, hey, I see 3 negatives here. But you really don't. What there really are here are 2 negatives, not 3. And the reason I say that is that these terms in the denominator here are being combined under the operation of subtraction. Okay? What I need to do to properly see what's going on here, remember, it's only in multiplication and division, and when you're talking about rational expressions, fractions, that's just another way of expressing division, isn't it? Only common factors can cancel. And you can consider like a negative one as a common factor. If there's a negative one in the denominator, they cancel each other out. But what this actually is, you need to actually understand r plus s over a negative e minus b is this. A negative r plus s over, I'm going to factor out a negative 1 from those two terms. The negative 1, or just a negative. You can just put a negative out in front of the parentheses if you want to. And rewrite the denominator like that. So really, there are just two negatives here. Now, they're going to end up canceling. And so my final answer looks like that. Let's try another one here. Okay. Let me okay. Rewrite that as a fraction whose terms are positive. What should I do? I bet you did. Just move the negative. Yeah. Yeah, that's what you do. So you do have a question. Yeah. Sometimes, and I understand that, sometimes when you're listening to descriptions of this stuff, how to do it, it can be like, but then when you actually see how it works in problems, you can it'll start to settle in a little bit. Yeah, just move the negative to the outside of the fraction box. There's just one of them there. So just move it out here. That's what it should look like. You move it.
What was the direction?
The directions are again to reduce to fractions in terms of positive. So right now, I know the overall value is still negative, but the terms themselves are now understood as positive numbers. That just move the negative. What I want to see here is if the overall value of the fraction is positive, it's going to look like that or like this. You're not going to see any negatives anywhere. If there's a negative to be had anywhere, I want to see it written out in front. That's all I mean by that. And if you see terms added together through the operation of, let's say, subtraction, factor the negative out of all of the terms. Don't make the careless mistake and go, okay, I see 3 negatives here, so I'm going to stick a negative on the end of that side of here because I know 3 negatives equal to negative, right? Don't do that because there's not 3 here. There would be 3 on problem number 3 here if the problem had read instead. But the problem had read instead something like this. Let me use this. A negative r times s over a negative u times a negative b. Then yeah. Then I'm looking at 1, 2, 3 negatives because they're all factors now. But these are combined through the process of subtraction. There's really just one. You factor out the negative 1 and you'll see that there's just 1 here. Because if you need to know that an odd number of negatives is going to produce a negative answer. And an even number will produce a positive. 2, 4, 6, 8, 102, 644. An even number is going to produce a positive number. Okay, an odd number is going to give you a negative. So just look at number 7 and tell me how many negatives are there? 1, 2, or 3? There's just 2, isn't there? Yeah. What about number 8? Are there 1, 2, or 3 negatives there? 1, 2, or 3? 2. There's 2 because you've got in parentheses a negative a minus b. You can factor out that negative 1. Okay, and then you have b times a negative b now times a plus b. Yeah, let's look at number 8. We'll put number 8 right here. A negative a times b plus c times b negative a. Now,
this is like making that thing where there's and it's just confusing.
I don't see that.
Gotta speak this one, okay? These on ACT work. Okay, so this negative out here in the numerator, that's obvious, there's one. But again, these numbers being subtracted. There's two negatives. Really, there's two. If there, you know what? If this is red, negative A over B plus C over B times negative A minus B minus C minus D, guess what? There's still only two. No, and the reason I say that, because all of these terms are combined under the order of the fraction. I can factor a -1 out of all of this, and still there's one negative. They're not multiplied together, they're added through the process of subtraction. There's just one negative. It doesn't matter how many terms are added together. There's a subtraction sign in there. There's 100 subtraction signs in there. It's still just one negative.
But if it's separated like that one, would it be different?
Yes, it would be. Yeah, if it was a negative A times a negative B times a negative C times a negative D, then yes, then there would be 1, 2, 3, 4 negatives down there. Yeah, if I had done this instead, and said, you know, reduce that, then yeah, you better look at this as 1, 2, 3, 4, 5 negatives. Okay? That's the difference. Okay, so I want you to do one. Wow.
Yeah, so once you get to how many negatives there are, how do you determine if it's,
If there's an even number of negatives.
or remember, if it's going to be a negative or a plus on the outside, or?
Yeah, if there are an odd number of negatives that you count, then just add one negative out in front. If there's an even number, don't do it at all.
So what's the answer to number eight? What's the answer to number eight?
Well, since there's two negatives here, what happens? They're positive. Yeah, that's going to end up being a negative here. I changed that to a plus. This negative is going to be gone. And so what happens is my two negatives cancel, don't they? They're gone. So my final answer is, well, you erase those two negatives and that's it. Yeah. No, because there's an even number of negatives and so they cancel. Okay? So I want you to do 1 through 8, and already worked half of them, or more, whatever. So 1 through 8 on page 71. Now, go ahead there, Tom. Come on, you ain't getting this. Don't rely on Miss Morgan to get it. All right, get it here. Okay. Let me do one more. Your next assignment is going to be one. I'm going to say 1 through 6 on page 72. Okay, 72. We're going to do 1 through 6 today.
One day a week.
Well, that's your homework.
So then, yeah, now no weeks.
Now, what I want to do is the example problem. The directions are here. Reduce the fractions that are in lowest terms. Okay, if I were to tell you, reduce, I don't know, 6 over 18. How would you reduce this? 1/3. How do you know it's 1/3? Okay, is this 1/3, everybody? I mean, I agree. The technical way to understand how to reduce this is to factor the numerator and denominators down to their prime factors, and then cancel your like terms. So 6, in terms of its prime factors, is 3 times 2, right? What about 18? What are the prime factors of 18? You might need to make a factor tree to see this. 9 times 2. Yeah, no matter, if you went 6 and 3, no matter how you decide to break it down, you're still going to come to the same prime factors. If you decide to say, 6 times 3, that's still going to be, 3. You still have 2 3s in the 2, no matter how you break it down. So I don't really care what route you go to. If you break it down to the prime numbers, you're going to come to the same answer. So what happens here? Cancels, cancels. Now, when you don't see anything left up in the numerator, don't get me a 0. Okay? Don't say your answer is 0 over 3 because you don't see anything. After you see this a lot. If there's nothing left up there, after you've canceled everything, there's always an understood 1. Okay? So your answer is this. You see intuitively that that's what it's going to be if you don't do all the math I just did. All the math gives you the mathematical justification for doing what you intuitively know, saying 6 over 18 is 1/3. Now, why do I go through that? Because let's look at your example problem. Y'all, I know you're real fond of factoring. Like I said, you can't get away from it. You shouldn't have this to factor as heavily as you did in chapter 2. I don't think that you will, but let's see. If you do, you definitely won't have to do it as much. But looking at the example problem, a squared, this is the example problem on page 72, okay? You have a squared minus 2ab plus b squared over b squared minus a squared, okay? Now what we've got to do, the directions are to reduce this to lowest term. Remember, common factors cancel. We have to factor it out. The numerator is a perfect square trinomial, and it's going to be a minus b times a minus b, where a minus b in parentheses squared. I'm going to leave it like that for right now. B squared minus a squared is the difference of squares. How does it factor? B plus a and b minus a, right? Can I be real careful here? I don't want to offend anybody in here. If any of y'all struggle with dyslexia, because if I look at some of your work, I kind of wonder if you do. If you do, cool, man. Some people deal with that. I want you to work these problems slowly because you might accidentally try to reverse the order of these terms. I saw some of you guys and the problems that you gave to me for the test is you inverted the order of the terms in factoring, and sometimes it didn't cause a problem with your answer, and sometimes it did. But the reason I say that is b minus a is not the same as a minus b. Y'all understand that? It's like 3 minus 2 is not the same as 2 minus 3, is it? They're negative reciprocals. So you can't just flip those around with a negative and if they're two, b plus a is the same as a plus b. When they're added, I don't care the order. But, you've got to be careful when there's a minus sign in between the terms. Now, so what have I got to do here? I'm going to cancel my common factors. Now, there's no a plus b's in the numerator, so I know this one is not going to cancel. B minus a almost looks like one of these a minus b's, but they're not quite the same. But some of y'all indicated the ability to do this. I don't know if you found it on the internet or somebody helped you, but you can actually invert the order of these terms if you factor out a negative 1. And therefore redefine the b right now is understood as positive and the a is negative, right? So if I factor out a negative 1, I can define that b is negative and the a is positive. Y'all understand, let me say this, y'all understand that b minus a is equal to a negative of a minus b? Let me multiply this out so that you can see it. If I multiply this out, what does that negative do? It changes the sign on both terms, right? This becomes a negative a plus b, right? And a negative a plus b is the same as b minus a, if the order of terms are inverted. You can invert the order if you carry the negative a. So what I'm going to do is rewrite b minus a like this. And so now my problem is going to look like this. I've got a minus b, then I'm going to have a negative out here in front of the terms in my denominator, so that now I can cancel this. And my negative goes out in front, with that factor left up there and this one left down there, and that's my answer. You can do that one. Nothing on these couple of pages. I'll give you some more fun to do tomorrow. That's like the hardest example, well, one of the hardest examples. I guess there may be a couple others that are harder, but what I want you to do, what your job here is on 1 through 6. On page 72. That's your next assignment. I'm going to stop now, okay? Your assignment is to reduce those to lowest term. Okay? Maybe once you do it, you might find it's not quite as hard as you thought. I don't know. The only way to find out is to get it in class. Okay? Let me say this. Number 1 should be easy enough to do, okay? Looking at number 2, a squared b, c to the third, a, b to the third, c. Just cancel. What you might want to do with ones like that, I don't want to extend this page too much because if I post it, you won't be able to read it. A squared, this is, if it's confusing to you, the reason that, or y'all should remember, right, that in division, you know how we subtract exponents? That's what you should do here. If you're not sure what to do, then write these out as prime, in their prime form. A squared is a times a, b, and then 3c, right? That's the numerator written in expanded form. You do the same thing in the bottom, a. They want to keep the letters up underneath each other as best you can. Well, you may not be able to. There's 3b, and then there's 1c. And cancel all the like terms. There are factors. Since all these are multiplied together, I can cancel. Okay? And what am I left with here? A times b squared over what? Yep. That one's done. Now on number 5 and 6. I want you to be careful with 5 and 6. There's a GCF that's going to have to come out, and those GCF will be what cancels. Those parts may be what cancels. You won't be able to see what cancels until you pull out the greatest common factor in number 5. Okay? You're just not going to. Let's do that one, and then I'll stop. Number 5, 2x squared. The more I do here now, the less y'all got to do tonight. Plus 4xy. 2x plus 2xy. Okay, let's look at the numerator. What is the greatest common factor in the numerator? Can y'all see it? What's the greatest common factor in the numerator? 2x, keep going, 2xy. They both contain a y. So 2xy, okay? Now once I factor that 2xy out, what's left? And what's left in my first term? If I factor 2xy out of 2x squared y, what's left? Just x, isn't it? Okay, let's put our plus down. What if I factor 2xy out of 4xy, what's left? Yeah, just 2. Okay? Now, what about my denominator? What's the GCF here? 2x. What goes in here? Y. Yep, that's it. So you've got, well, 1, actually, remember, if I factor 2x out of 2x, what do I get? 1. Don't forget this. There's a 1 here. And then put your plus 1. Okay? Now, so what cancels? The x plus 2, the 1 plus y, they're not going anywhere. I'm almost done. Or you got a question? Yeah. Now, the 2's here will cancel. They're common factors. The x's will cancel because they're common factors. So what am I left with? I am left with I don't want to extend the page again because it'll make it harder to read when I post this on the web. So let me do this. Your final answer is y times x plus 2 over 1 plus y. Don't try to cancel these y's. Do you know why I can't cancel these y's? Because y in the numerator is understood as a factor. With the plus sign in between, with the 1 and the y, 1 plus y together collectively is considered one factor. And so I can't cancel these y's, so don't try. I couldn't cancel that y unless this one was combined with 1 as well. Yes, you don't go any further than this.
You get the 2 after, x, y, what is that again? The first one is the GCF, and then
Yeah.
what's left, and then.
Yeah. When I factor out the GCF out of the numerator 2xy, what's left is x plus 2. I factor the GCF out
I'm
of the
saying the 2 is,
where
what, how many times? 7 times.
say that one more time, Christine.
Like the 2xy is the GCF.
Yeah.
The x is what's left, and the 2 is.
Oh, okay. Well, remember when I factor out that 2xy in this case from each term, it's like we're dividing each term by it. And what I'm saying here, 2xy divided by, or 4xy divided by 2xy. I'm saying,
Did you have all of them?
Yeah. You have to divide each term by the GCF. So what happens here is this. Yeah, if I take this, what I'm saying here is that, see the x's here cancel, the y's cancel, 2 goes into 4 twice, and so that's why I come back to here.
What about the
2.
bottom one?
Okay, what about the bottom?
Like, where it's 2x plus 2xy, and then I get the 1, I think it's y, so you not do like the last step, like build it out. You not do it.
What I did, when I found 2x as my GCF, what I did is I divided both of these by that GCF. You see that? And so that's where the 1 came from. Okay? And then the 2's cancel, the x's cancel, I'm left with y, and that translated to just a 1. Okay, let me go ahead and stop there.